Hey guys, it's Solbyte, and today I'm going to be going over linked lists. Linked lists are usually kind of like the starting point for whenever you are learning data structures. So they're very simple as long as you kind of understand what pointers are, and as long as you already kind of understand like what an array is, because they are similar to arrays in a way, like kind of in the way that they're both lists and they're both like collections of different values and data. But we're going to see kind of the key differences between a linked list and an array. So what exactly is a linked list? So a linked list, kind of by its definition, is a collection of elements where each element stores two things, okay? It stores the value, and it also stores a pointer pointing to the next element in the list, okay? So it's very, I mean, you can think of it as a linear collection. And in fact, a lot of websites actually define it as that. It's a a linear collection of elements that where each element points to the next element, right? And each element is called a node, right? So the first node has the value of the first node and a pointer pointing to the second node. And the second node has the same thing, a value, and a pointer pointing to the third node. And then at the very end of the list, we have the, whatever the nth node that has the value and points to null. It points to nothing, basically. And yeah, so before I actually show you guys an example and start implementing it, I want to kind of tell you guys how it's a bit different from an array, because they are similar, but they have very key differences. So an array is stored in a specific memory location, and the values are stored one after the other, right? So they're all kind of stored together, right? But a linked list, all of the elements, all of the nodes are stored randomly in the memory. So therefore, what this means is that there's actually a very unique limitation to linked list where, like in an array, we can index over the array, or we can access a specific area of the array, right? Like we can access the third element of an array just by using the index. However, with a linked list, we cannot do this. Like if we wanted to access, let's say, the third element of a linked list, well, we would need the second element, because the second element actually shows where the third element is, right? Without the second element, we have no idea where the third element is. And also, if we want to actually access the second element so that way we can get to the third element, we need to also have access to the first, or the head node of the linked list, because that points to the second element. So that's kind of a very key difference. We can't exactly access like a specific area of the list except for the head node, which is the first element of the list. That's the only location we know about the linked list. And from there, it points to each, each element after that. So another thing to kind of keep in mind is that a linked list actually requires more memory, because a linked list, as I already said, holds two things. It doesn't just hold one thing like an array, or, like a specific element of an array would, where it just stores the value. Every element in a linked list has to store the actual value in that element, as well as the next element, right? A pointer to the next element. So it stores two things. So therefore, if you're looking for having, as little memory as possible, an array would maybe be a better option than a linked list. But I mean, there are some cases where a linked list actually kind of shines above an array. Like for example, an array is fixed, right? We can't have a dynamic array, right? I mean, you can do dynamic memory allocation and all that kind of stuff. And I just made a video about vectors, which, are really great, but a linked list is dynamic. So we can always add new things to it, delete things from it, etc. And, it changes its size as far as the size of the linked list goes. Whereas the array, if you delete something, it's still going to remain the same size. So anyways, enough yapping. We're actually going to go ahead and show you guys, or I'm going to go ahead and show you guys kind of how we can implement this. So the way that we can do this is, obviously I said that each element in a linked list is a node. So let's actually go ahead and create a node. So let's just use a struct. If you guys haven't seen my struct video, please go check it out, or check out someone who maybe is better at explaining it. I don't know. But anyways, struct, we're going to create a struct called node. And let's say we want our elements to hold a integer value. Just do integer value. Okay. And now we need to create for our node a node pointer to the next node. Okay, so we're going to do node, going to make it a pointer, and we will call it next. All right, so two things. We have the value of the node, and we have a pointer to the next node. Perfect. And this is really all we need. This is really all we need for each element in the linked list. So now let's actually go ahead and create the linked list ourselves here in the main function. So the way that we do this is we need to create a pointer, what we will call head. The first element of every linked list is usually called head, right? And this is going to be the one that we have access to. So we're going to set it equal to a new node. All right, and I'm actually going to create 4 more of these, so that way we can kind of, go through the list and maybe print some stuff out. So we're going to name the second one second, the third one third, the fourth one fourth, and if you had to guess, what do you think this one would be called? Yeah, that's right, the fifth. So now let's go ahead and go down here and actually implement how we are going to use, or sorry, how we are actually going to create the linked list. Because right now these are just a bunch of pointers pointing to a node that just holds nothing, basically. Let's go ahead and start with the head node. So we're going to use head, and instead of dot, if you guys don't already know, with pointers, we need to use the arrow. So we're going to do head and use an arrow, and we will go ahead and fill in the value. So let's just say in the first one, we want to hold the value of 10. Let's do that, right? And now let's go ahead and define what we want the next value to hold. And for the next value, right, for the next, the pointer pointing to the next node, we're going to assign it to the second node. Perfect. So what this is doing is now the next pointer over here in our first node is now pointing to our second node. Now let's go ahead and fill in kind of the rest of these guys. Let's do value, and let's make it 20. Why not? And then we'll do second next. And if you had to guess, what do you think we're going to do? You're correct. Third. All right, so I went ahead and actually filled in these other nodes here. And for the fifth one, I'm going to show you guys kind of what we want to do for that one. Since it is the last node, we're going to go ahead and fill in the value, make it 50. And for the fifth next pointer, we're going to just assign it to null. So it is a null pointer. All right, and perfect. We now have a linked list. Nice. So what is happening here is the head node, this one right here, has a value of 10, so we can store something in it, and a pointer pointing to the second node. And then for the second node, we have a value of 20 and a pointer pointing to the third node, and vice versa for the rest. So awesome. Now I kind of want to show kind of how this works. So I'm going to make a function up here. I'm going to say print linked list. All right. So we're going to use this function to print the values of this linked list by going through the linked list in the way that a linked list works, right? By using the pointers. And yeah, so what do you think we need to pass in here? So what do we have access to? Well, we have access only to the head pointer location. It's the only thing that we have access to. So therefore, what we're going to do is we're just going to make, we're going to pass in for our parameter a node pointer, and we're just going to call it node, right? And what is going to be meant to be passed in here will be the head pointer. Okay. So now what we want to do is let's do a while loop. And what we want to do is we want to see out the node's value. Okay. We'll add an inline, and then what we want to do is we want to set node equal to the next node pointer. All right, so now node will equal whatever the next node is. So therefore, if it's the first node, or sorry, the head node that we're doing this first iteration over, then node will be set equal to the second node, and then it'll iterate over the second node. And we're going to do this all the way until node equals null. So whenever it equals null, it's just going to stop. So we'll just do this. And yeah, perfect. So let's actually go ahead and test this now. We're going to do print linked list, and we're going to pass in head. All right, so now let's go ahead and run this in our terminal here. And here we go. We get 10, 20, 30, 40, and 50. So what's happening is for the head node, we're printing out the value of the head node. Then we're setting node equal to the second node. Then for the second node, we're printing out the value for the second node. And then we're setting it equal to the third node. Print out the value for the third node, and then vice versa, all the way up into the fifth node, where it prints out the value of the fifth node, and then sets it equal to a null pointer, which from that point stops the while loop because node now equals null. Perfect. And so yeah, this is a very basic example of a linked list. There are some more sophisticated methods as far as implementing a linked list, which I intend to go over probably in my next video, which I'm also going to introduce doubly linked list. I can never say that. Double linked list is usually what I say, but yeah, a double linked list where you can also access the node previous instead of always accessing just the next node. So that'd be pretty cool to go over. Definitely look forward to that one. So yeah. And if you guys have any questions, please let me know in the comments down below. I'm of course going to leave some references to some more in-depth guides in the description. And yeah, thanks for watching.